Hello and welcome to York University Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. You'll now find us wherever podcasts are distributed. I am Paul Mackin, one of your hosts this evening, and I'm joined with Professor Mary Helen Armour. We are broadcasting live from the Allan Carswell Observatory at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live on Monday at 9 p.m. local Toronto time, or currently 1 a.m. Universal time Tuesday morning at York U Observatory. We also run with our online public viewing feed, or as we call it, the OPV, which is operated by the observatory staff. Normally, we try to have some live images to show, but we're in midterm season, and tonight the domes are closed and our team is studying, and we'll be looking at some wonderful archival images instead. To navigate to our live show or learn more about us, please visit our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. If you have questions or comments about past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Instagram with the handle at YorkU Observatory, or on Facebook at Allan I. Carswell Ob. All of our programs are free, but we would appreciate any donations you may wish to make. Please see our website at yorku.ca/science/observatory. We'll be monitoring the YouTube chat for questions and post content. Our theme for today is the skies are alive with activity, just not necessarily the activity you hear about on social media. Looking outside my window right now, I see clear skies, and we are now well into autumn and the skies are dark. We're just shy of a new moon. Saturn is past opposition and nicely placed for viewing in a small telescope, but the rings are quite narrow with respect to us right now. Jupiter is rising around 11:30 p.m., and Venus dominates the dawn sky. We have a couple of other objects in the sky tonight, which we'll talk about later. How about you, Professor? How are the skies where you are?
A little erratic. It sort of clears and then clouds over again and clears and clouds over again. It's sort of typical October weather where you'll have some clear skies, but a lot more rain and overcast.
Yeah, it's a bit here. It's a bit better. I'm a little south of you. I'm a bit closer to the city. I probably don't have as good skies as you do, but they are clear where I am, and they're expected to be clear until about 7 a.m. I've got one of my scopes set up, and I've got a bunch of observing planned. We're still furiously capturing images for the Allan I. Carswell Observatory annual calendar, and we'll be plugging that shamelessly through the end of the year. So I'm just warning all our listeners now. I'd like to kick off with this week in astronomy history, and your first story, Professor, ties into one we're going to be talking about a little bit later. So I'll turn it over to you.
Yeah, so just about 8 years ago now, we had our first recognized interstellar visitor. Now, prior to this, we had suspected for a very long time that there were comets that came in on what we called a hyperbolic orbit, which means it came in kind of a U-shaped orbit, would go around the sun and then sort of shoot off out of the solar system again. And these had been speculated again for a long time. If you've ever read, of course, Arthur C. Clarke's whole Rama series, that was sort of exactly the orbit those were on. And so on October 19th, 2017, what we found was this long, sort of slender asteroid that is now called Oumuamua, and I'm probably pronouncing that wrong, and I apologize if I am. And it came in and it was moving incredibly fast. Like this was a quick moving object. They didn't have long to observe it, but it clearly had come from outside the solar system. And although we suspected this had been, going on quite a bit, this was sort of the first one that was really recognized. And it wasn't round, it was sort of more long and cigar shaped. So for all those of us who had read Arthur C. Clarke, there was this sort of, tick in the back of the head. Is this like another sort of Rama spaceship? Because it seemed to be about that size and shape, which was quite interesting to those of us who were familiar with that. But this was quite unique because this was the first recognized one. And it was captured with pan stars, but over the next, couple of years, we have found a few others. Of course, Comet 21 Borisov came along a couple of years later. And then just as recently as July of this year, of course, we had 31 Atlas. And these, are the first three officially recognized visitors from outside of the solar system. Obviously there've probably been a lot before that, but it's just in the last sort of few years we've actually had the technology to really sort of capture and recognize and identify these things as extrasolar visitors coming from outside our own solar system. So these have been so it's kind of been a very interesting time to live in because the technology finally allows us to capture it. Now, this object was moving fairly quickly, so it was only there for about 4 months before it became too faint to observe any further, which is quite a short time period. But it really opened sort of, I guess, a lot of, areas of inquiry because now we knew for sure that yes, you do get these fast-moving objects coming through the solar system from outside of it. And, they tried to track back sort of where it may originate from, but these things are quite complicated to do. And you don't quite know what else may have affected it before it gets to your own solar system. Um, so
And
yeah,
and
that's
of,
kind of
and of
interesting.
course, there's always when these interstellar comets come along, it takes us back to Rendezvous with Rama. There's usually one professor down, I think he's at MIT, who basically says it's interstellar spacecraft, and there's never been any evidence that it's an interstellar spacecraft, and I think you'll also, and we'll come back to the social media theme throughout today, but you hear a lot of that on social media as well. It's a comet. It's an unusual comet. Atlas is 3I Atlas is definitely an unusual comet, but it's behaving like a comet. It's got a different chemical mix, you know, but yeah, it's these are comets, right? And you don't really get a I don't know why there's this insistence that everything is suddenly an interstellar spacecraft whenever it comes from out of the solar system.
Yeah, but people have been fascinated by the extraterrestrial thing for ever since about even pre-World War One, when you started having Goddard and some of these others developing rocketry. I mean, it really goes back to Percival Lowell, who first started speculating about, quite publicly about life on Mars, and then you had H.G. Wells. And I think people just became fascinated by it, right? And of course, it leads
Yeah,
to so much speculation and, conspiracy theories and all kinds of stuff. But it sort of brings out that whole, I think, element of human behavior when you have these possibilities. So, I mean, this one really did attract a fair bit of attention, some of it good, some of it a little weird. Um, but I guess for all the science fiction buffs, we immediately started thinking when they talked about the shape of this thing, of course, the whole rendezvous with Rama thing. Now, didn't really think it was likely, but it always sort of tickles the imagination when you get these kind of things happening.
and of course you mentioned that we've got the technology now, and Vera Rubin is it's already through its test phase, and we're setting science operations to begin really any time now. And it has the capability. It's thought that it will produce the initial estimate is produced evidence for one per year interstellar comet. Uh, I actually think we probably underestimated that a lot. I think there's probably a lot more of these things than people currently consider. There's a lot of activity in the universe and in our galaxy and in the local part of our galaxy. So it wouldn't surprise me if we end up seeing quite a few more of these. What I keep hoping for is that someone will come up with the bright idea of putting a small fleet of satellites in orbit that we can swing out to intercept one of them if it just happens to be in the right place and get some evidence, some data. That would be fascinating. But
Oh yeah, but the thing is, a lot of these things, the problem is they're so fast moving.
they
That
are.
would be the
They are.
challenge. The sheer amount of fuel you would have to carry to catch up with it in that short amount of time.
Yeah.
I think that's the bigger challenge, right? It's simply not that easy to,
Uh,
react that fast.
I completely agree. And what I would say is that for uh, you know, for it to be on a hyperbolic velocity, by definition, it has to be going really fast, or it wouldn't be. It would be, in a parabolic or in an elliptical orbit. So yeah, it's tricky, but I think we'll eventually get some interesting data. But I this reminds me of another type of object that was not really known um, for until relatively recently. And I've got sort of two dates for this discovery. But on the 18th of October, 1977, and I think it was discovered on the 18th of October and confirmed November 1, Chiron, which is the first centaur to be discovered. Now, in planetary astronomy, a centaur is a small solar system body, kind of like an asteroid, with exceptions, that orbits the sun between Jupiter and Neptune. Now, remember our basic structure of our solar system. We've got between Mars and Jupiter, we've got the asteroid belt. A little further out, there's a whole school of thought about why this is. You've got these other objects called centaurs, and they're probably more ice-based and less rocky because they can show comet behavior as well. They also have unstable orbits, mainly because they're in this large space with big planets going by and so on. So they only have dynamic lifetimes of a few million years. There is one known centaur, 514107, and I'm going to try and pronounce its name, Chi Ep Ak-Oa. Well, I don't know. But it may be in a stable orbit, though it's retrograde, it's going backwards. And centaurs typically exhibit the characteristics of both asteroids and comets. And this could become a theme in a planetary astronomy midterm that's scheduled for tomorrow for several of the people on our crew. Why do they have comet behaviors when they're out past Jupiter and not when they're in closer than Jupiter? But they're named after a mythological centaurs. And if you like the Harry Potter films, there were centaurs in Harry Potter, which were a mixture of horse and human. Observational bias towards large objects makes the determination of centaur population difficult. So let me explain what I just said there. We can see the bigger objects because they're further out. So we don't really know if there's a lot of small objects. So the estimates of the number of centaurs in the solar system bigger than 1 kilometer in diameter range from as low as, kind of 50,000-ish to more than 10 million. Now, the first centaur to be discovered, as centaurs are defined, was 944 Hidalgo, which was in 1920, but it was not recognized as a distinct population of solar system objects and part of that population until the discovery of 2060 Chiron rather, in 1977. And this is it's a big one. It's not the largest. The largest confirmed centaur is 10199 Charleco, which at 250 kilometers in diameter is a mid-sized main belt asteroid, and it's known to have wings, and it was discovered in 1977. Now, no centaur has been photographed close up. That there is evidence that Saturn's moon Phoebe, and you can look this up online. It's a fascinating looking object, which was imaged by the Cassini probe in 2004, may be either a captured centaur or have originated in the Kuiper Belt. In addition, the Hubble Space Telescope has gleaned some information about the surface features of 8405 Asbolus. Now, Chiron is a recognized minor planet, so it is a bit bigger, but it also exhibits cometary behavior and is one of the only four minor planets or asteroids with rings and the only comet-like object with them. So these are hybrid objects, and again, because they are further out from the sun, they can retain ices more readily than asteroids can, which is why they start to exhibit some comet behavior.
Yeah, it's like I said, as technology with CCDs and all kind of detectors have gotten better, we found more and more like weird and wonderful objects in our solar system. And, even with the Kuiper belt out there, I mean, the number of odd things that could be floating around and detritus from the formation of the solar system and weird things that have been created as, you get the collisions and breakups of planetesimals and sort of cosmic billiard table out there. It's fascinating all the different kinds of objects you see and the different gravitational behaviors you see. I mean, it's like I said, that's when you've got multiple small bodies tugged by big ones, you get that sort of crazy n-body problem that leads to such weird orbital characteristics when you're pushed and pulled by so many different, gravities of other things around you. So, you get these kind of really weird orbits. Um, you
You
wonder,
do.
yeah,
You do, and what's interesting about it is that, as I said, as we discovered this helped us develop the model of the formation of the solar system, and there's something called the freeze line, which is where did volatile, where was the sun's influence so great that ice is subliminated, so they basically evaporated. They went straight from solid to gas and were blasted out by solar wind, which is why objects in the inner solar system have a tendency to be rocky. Mercury, Venus, Earth, Mars. Then you've got the asteroid belt, also rocky. Then you get Jupiter, and you're in the range of, you got more gas out there. More, they retain their volatiles better. A lot of hydrogen and helium, lighter atoms. Then you get out, even further, and you start to get into these centaurs, which kind of act like rocky comets. And this helped us evolve this idea of how a current idea of how the solar system formed. So we learn a lot as we find things like this. And Chiron was only discovered just less than 50 years ago. This is relatively recent in astronomical history. But speaking of rocky inner planets, Mary Helen, I think you want to tell us about one.
yeah. So I have been following the Mercury missions for quite a while now because I became fascinated with Messenger years ago as the first real mission to Mercury. There had been flybys earlier by some of the mariners, but despite the fact that Mercury isn't all that far from Earth, it's actually very difficult to reach because it is so close to the sun. So August 20th, 2018, the Bepi-Colombo mission launched. This is a joint mission between the Europeans and the Japanese, going to look at the planet, but also has sort of a separate piece, a separate orbiter that will also focus on Mercury's magnetic field. Because surprisingly, even though Mercury is quite small, it's got a massive iron core, but it also has a planetary magnetic field. So this mission is going to look at those, and the whole talk of gravity really comes back when you're looking at something like the Bepi-Colombo mission. It may have launched 7 years ago now. It's not actually going to go into orbit around Mercury until November of next year. Because when you're trying to get to Mercury, you can't go there directly because you try and fly too directly, you just end up getting dragged into the sun by the solar gravity because it's so powerful. So you kind of got to sneak up on it and spiral in gradually. And Bepi-Colombo will have to fly by Mercury 6 times. The most recent one, actually, the final one, was in January of this year. But it also had to fly by Venus twice to kind of slowly spin it in until it can actually go into orbit around Mercury. Messenger had to do the same thing several years ago. It also took it about 7 years to get from Earth to Mercury, even though we can get to Mars, which is actually further away, in something like 3 to 6 months. So it shows you how much the gravity challenges you when you were trying to get there. Now, Bepi-Colombo was really designed to be a follow-up of the Messenger mission because prior to Messenger, we only had imaged about 30 to 40% of Mercury's surface with your Mariner flyby. So Messenger actually was really cool because it did manage to image most of the surface. And again, coming back to this idea of the more we find out, the more, like we're finding a lot of our assumptions were wrong. There was kind of this assumption that there's no way there could be water on Mercury because it's too close to the sun, it's too hot. And yet there is abundant evidence that there is frozen water around the poles and some of these shadowed impact structures. So it's really quite interesting to see, like how much our knowledge of Mercury improved. Because with Mercury, you can't even turn a normal telescope on it because it's too close to the sun. And the optics of something like a Hubble or even sort of a normal, even the telescopes we have at York, it's just kind of risky because you're too close to the sun, you'll burn out your optics. So Mercury, despite the fact that it's not that far away, has been a very mysterious world. And Bepi-Colombo was designed as sort of a follow-up to the Messenger mission to see, what can we learn? And in particular, Mercury's magnetic field is kind of fascinating because Mercury rotates on its axis very slowly. So how do you get a dynamo inside of Mercury that could produce this magnetic field? There's some very interesting questions around this. Whereas when you look at Venus, it has no planetary magnetic field. When you look at Mars, it has no planetary magnetic field. And yet here's Mercury um, with this planetary magnetic field. Now, it's got a very large iron core, uh, but Venus has a fairly large iron core as well, we think. So there's some very interesting questions to be asked. Unfortunately, we'll still be waiting uh, a little over another year for it even to arrive and get into orbit. So, it's probably a good 16 months before we really have any results and start to see what comes back from this mission. But, it shows you how the patience you have to have with some of these missions because it launched 7 years ago and it's still got more than another year before it gets there. So it's quite a fascinating mission, and we've gotten so much better at exploring the solar system and finding out so many cool things in the last couple of decades. So
Yeah, it's interesting to me. The architecture for Bepi Colombo is it's a bit unusual because when they're flying by, they actually can't, like normally when Messenger flew by Venus or Earth or Mercury, it was capturing data all the time. But Bepi Colombo is more limited in that regard because it's actually three spacecraft. There's a carrier spacecraft and then two satellites. And the carrier spacecraft is designed so it's the two satellites are contained within the carrier spacecraft. So the carrier space, the actual satellites can't get a clear image, really a very clear image of Mercury as they fly by it. But the carrier spacecraft is using an ion drive. Again, part of the problem is how do you slow down enough to spiral into Mercury's gravity? So they're using, slowing down through gravity assists, but they're also constantly decelerating the spacecraft as the sun's gravity pulls it in. But when it gets into orbit, it will abandon the carrier and the two satellites. One will go into a polar orbit. It's a Japanese spacecraft, and the other one is going to be in an equatorial orbit, which is the European spacecraft. And one is the I think it's the Japanese one is specifically tasked with trying to understand the magnetic field. It's going to be an amazing mission when it gets there, but good Lord, it takes a long time to get out that far. And sorry, to get there, and it isn't that far. It
yeah,
really isn't that far.
I mean, it takes it almost as long to get there as it took for this New Horizons to get out to Pluto. It's quite it's quite the time consuming mission when you think about it. And it was interesting because I did see some of the images that Bepi Colombo took as it flew by Mercury on some of its previous flybys. And they're quite interesting because one of them was right over one of the poles. I don't remember if it was the North or South Pole. But it's kind of interesting because, as you said, they're kind of two of them mounted on this other superstructure. All these pictures have a picture of like an arm from the probe kind of sticking out across the image, just because of the way the cameras are sitting, that they're able to take some images with. But it has managed to get some images on flybys, but no, not as many
Absolutely,
as
yeah.
you might with a different configuration, like something like the Messenger mission of a few years ago. So
And one of the coolest things is when it does get into orbit, one of its tasks is to find the impact crater left by Messenger. They want to actually measure the impact crater because that'll give them some idea of the surface dynamics and the regolith structure and so
yeah.
on. So that's actually going to be really quite fascinating. And as you said, of course, Bepi Colombo flew by Venus. And Venus is kind of the poor sister of the solar system. I think it just doesn't get it doesn't get the attention it probably deserves. But on October 25th, 1975, so just shy of 50 years ago, uh, Venera 10 soft landed on Venus. The Soviet Venera 10 probe landed on the surface of Venus. The mission, which included a lander and orbiter, returned along with Venera 9, the first ever pictures of the Venusian surface. The Soviet space program did really quite well with Venus landings. They had a total of 7 landers, and they were usually hybrid missions where they had an orbiter coupled with a lander. So 10 wasn't the first lander. That was Venera 7 in 1970. And Venera 7 recorded, the incredibly hostile conditions, uh, temperatures, 700-800 degrees, incredible Celsius, incredible atmospheric pressure, 90 times Earth's atmosphere. And the probes died very quickly. And it wasn't just the temperature and the atmosphere, the pressure. It was the sulfuric acid in the atmosphere as well. Venera 9, which was the sister craft to Venera 10, was able to send the first images back. But it was Venera 10 was the first probe that lasted longer than an hour on the Venusian surface. You know, that took some amazing engineering, and these things were pressure vessels. They were built like bowling balls. Imagine a bowling. You can go online and look at them, but imagine a bowling ball with the top bit carved off and an instrument suite on top. But they were pressure vessels, and they were designed to keep the inside as cool and pressure controlled as possible. And they did take some pictures, and the first pictures showed a flat, not quite molten terrain, but this is not Venus is not a lava planet. It is a very hot planet, and it's probably got a pretty pliable surface. The light levels were low. Again, you've got this incredibly thick atmosphere of carbon dioxide. You want to talk about a greenhouse effect. Venus has got it. I mean, Venus shouldn't, if it had an atmosphere like Earth, it wouldn't be as hot. It'd be hot, but it isn't going to be as hot as it is now. The carbon dioxide is capturing heat and retaining it into the surface. So the light levels are low, and that you could see, kind of you're on this kind of near lava plain, and you could see some hills off in the distance. And these craft had very short life expectancy. And the last landing, Venera 14, was in the early 1980s, and it lasted, again, kind of 60 minutes-ish, but it included a few other things. It had a microphone, and you could actually hear the wind. You could hear it had an arm to try and drill into the surface. So if you listen to the recordings, and this is all available online, you can hear it's a hammer drill. So it's hammering at the surface. You can hear it clicking and hammering away at the surface. And they captured all this information, and they did it very, very quickly. And again, Venus is kind of a shame because the Soviet Union did a very good job with it. America, the United States had a couple of Mariner missions, and then they had one spacecraft that they put in orbit, and it did a radar mapping of the entire planet.
Yeah,
Sorry?
most of the planet. That was Magellan, wasn't it?
Yes, it was. Yeah. And Magellan, they did a very good job with that. And then the Europeans and the Japanese have both gone back with Venus Express, and then the Japanese have also done a Venus mission. But there really have not been any follow-up American missions. They have two on the books now, but the NASA budget has been very badly cut. Da Vinci and Vesper, I think. I can't remember the name of the other one, but they are both basically probably scrapped, which is terrible shame. And I think they're partly constructed. So Venus is probably in the inner solar system for sure. It is the planet that needs the most notice. And then I think in the outer solar system, either of the ice giants. They desperately need an orbital mission as well, but Venus is kind of the lonely sister, and it's funny. You look at it; it's such a beautiful. You go out, get up early tomorrow before sunrise, and it should still be clear in the GTA. I'm told, and you can see Venus, and it's beautiful. It's just this beautiful, like absolutely white star hovering over the eastern horizon. It's bright enough to cast a shadow. It's incredible. And again, this comes to the theme is what goes on in the sky at night is wonderful in its own. It doesn't really need to be exaggerated, but we'll talk more about that later. And I think this is a good segue. We're at the halfway point. So time for some reminders. We are listening to the York Universe podcast. We are broadcasting live from the Allan I. Carswell Observatory at York University in Toronto, Ontario, Canada. Please look at our website at yorku.ca/science/observatory to join the chat if you have questions or want to see some of our content. Tonight, you're listening to Professor Mary Helen Armour and me, Paul Mackin. We've been discussing some historical items. If you're interested in our online public view, please navigate to our website and follow the links to join in that fun. And right now we've got M27, the Dumbbell Nebula, and we've got the Andromeda Galaxy and M95. They're wonderful images. And M95 just changed to M38. But these are wonderful archival images and absolutely great to look at. So, weather permitting this week, we'll be hosting an atrium observing event on the fifth floor of the Arboretum parking lot at Kiel campus on Wednesday. This is a great opportunity to come out and look through a number of small telescopes and see live what is going on in the night sky. If the skies are cloudy, then we're going to move this indoors to an observatory tour, which will showcase our 60 centimeter and 1 meter telescopes instead. But we won't actually do any observing with them. You just see them, and they're very impressive. Both are incredible instruments, and York is blessed to have York with our 1 meter telescope. We have the largest university-owned on-campus telescope in the country, and that's just such a great opportunity for our students. Tickets are free, and a link can be found on the website if you want to get them. Of course, donations are always welcome. And now for some items in the news. Mary Helen, I think a meteor shower coming up, I think.
So the Orinids are peaking sort of tonight and tomorrow. Given the weather, you may not see a lot of them, but the thing to remember about meteor showers is they're usually visible for at least several days, and in cases of some showers, even a couple of weeks after the peak. So if you can't see it tonight, it's not as big a shower as some. At a peak, you can get up to about 20 meteors an hour. So it's a fair number, but it's not huge. If you are outside and you are observing, if you look towards roughly where the constellation Orion is, you may see some of these. And of course, the thing to remember is all meteor showers are associated with some kind of comet. And the Orinids are kind of interesting because they're associated with Comet Halley. But interestingly enough, Comet Halley also dumps a second meteor shower onto Earth's orbit, which are the Eta Aquarids that happen in May. So Halley's Comet has a tendency to actually create two showers, which is a bit unusual because with most, it's just a single one, at least that's been identified. But in the case, oh, excuse me, of these two of these showers, they're both coming from the same comet. Now, Halley's Comet, it's been, a good 40 years since it came by, so that's the other thing that tends to affect showers. Generally, within a year or two after the comet passes, that's when you get sort of the most spectacular shower, and then the numbers will sort of slowly tail off and then suddenly peak again when it goes by. When we get into November, we'll have the Leonids that do the same thing, and they're a much more spectacular shower. But this is this one for this month. And the thing to remember is there are actually showers in most months. If you search online for just sort of meteor showers, you can get some lovely calendars of when they are likely to peak and when you are likely to see them and where to look in the sky from them. So, like over the next couple of evenings, they will be quite visible. You probably have to start a little bit later at night because Orion is not rising until a little bit later. But if you're going out around, 11 midnight, you will be able to see them. And of course, the sun is rising so late right now, you can probably actually see them early in the morning as well if you're up, an hour or so before sunrise, which isn't too hard when the sun is only rising a quarter after 7. So yeah, that's kind of the big activity in the sky right now. But I always found the shower kind of interesting since it is paired with another one in May that are both coming from the same comet. So I always found sort of meteor showers quite fascinating.
Yeah, and I was doing a bit of the back of an envelope calculation as you talked about Halley, and of course it was 86 that it was here, and as I measure that, that's 39 years ago, if I've got my math right. Pretty sure I do. And 39 years times two is 78. So, according again to my back of the envelope calculations, Halley's on its way back. It takes 76 years to go around the sun, and yeah, it's gone out. It's past its furthest point, and it's coming back in, and it won't get here till I think it's
2061.
2060,
Yeah.
2061. Yeah, but I doubt I'll be around. But I've got classmates who'll see it, and uh, and I did see it when it was here last time. It wasn't a particularly a great visit for this
Yeah,
particular comet,
I know.
but
It was a bit of a fizzle because it kind of passed a little bit farther away from Earth. I mean, it still comes in fairly close, but it's kind of on the opposite side of Earth's orbit. And I remember being a kid up at our cottage and having the binoculars and stuff out, and we looked and looked and looked and weren't able to find it because it was not really naked eye visible, which was the big disappointment because the
no,
previous one around 1910 uh,
was huge.
was huge
Was
because Earth
huge.
actually even passed through the tail actually sort of passed over Earth. So it was just an absolutely spectacular
Yeah,
event.
yeah.
Yeah.
You could go out and you could buy anti-Haley poison gas pills
Oh
in
yeah.
1910. Yeah.
Yeah.
Um, but it's interesting because the one thing that the 86 approach to Earth had, which we've never been able to do before, is we actually had a European Space Agency craft called Giotto, which got some great images. So we have a pretty good picture of what the peanut-shaped uh, 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 um, body of what Halley looks like, and again, this is stuff that you can look up, but it's interesting. I mean, people get very excited about comets, and I remember in the before Halley, there was another one, Comet Kahutek
Oh
in
yeah.
the 1970s, a total fizzle. I managed to see that one too, but but then you have Hale Bopp, which was a big success and was around for a long time. So you
Yeah.
never really know with comets,
Yeah. I mean,
which is which takes me, I guess, to my theme, one of my themes for today, social distortion. You know, a lot of people get their information from social media, and there are various algorithms, and the social media companies are tuning and tweaking what they send to us. And for years now, I've been watching everything from outright fabrications to extreme distortions of news and about astronomical events. I
yeah.
first became aware of this in 2006 or so, but it probably started 3 years earlier in 2003 when Mars was relatively close to the Earth. And, social media was kind of nascent at the time, but it reported there were social media reports that Mars would be the same size as the full moon, and this would never happen again in our lifetimes. Mars was, in fact, pretty large in the nighttime sky. It was, kind of 6 or 7 times bigger than normal. But not nearly as big as the post claims. For Mars, when it's at its closest, and that's when it's on the opposite side of the Earth from the sun. And that happens about once a year. So in 2003, it wasn't the same size as the full moon. It was 1/70th. That's 1/70. The size of the full moon. I think it was uh is yeah, it was. I worked it out. It was exactly 1/70th the size. It was a bright dot in the sky. And every year for a couple of months, Mars is closer and brighter. It's a bright dot in the sky. Mars is never that impressive to look at with the naked eye. It's a small planet. It's half the size of Earth. It's pretty far out. It's not not particularly reflecting a lot of light. Okay, so it's there. Astronomers find it interesting. Exobiologists find it really interesting. Geologists find it really interesting. And it's kind of got a cool pedigree because there's lots of stories about Martians and War of the Worlds and all that good stuff. But for the most part, Mars is a red colored, medium bright star in the night sky. Now, opposition for Mars has already happened in January 2025, and the next one is February 2026. So, my prediction is sometime around January 2026, you're going to see a lot of posts about Mars dominating the sky, and we'll never see it again in our lifetime. But so there is a pattern on social media that is to take a real phenomena and blow it way out of proportion, which brings us to the latest examples. There are a couple, but this one really caught my eye. On October 21st, 2025, after 15,000 years, comet C slash 2025 41 will pass just 0.15 million kilometers from Earth, closer than the moon. About 1.2 kilometers wide, it will shine brightly for weeks, a rare cosmic event. Now, this is my grammar and spell checked version of the post because the grammar was terrible, the spelling was terrible. And as with the Mars story, there is some truth to it. So, Comet C slash 2025 A6, not 41, also known as Comet Lemon, will be closest to Earth on October 21st, tomorrow. Okay. And also Comet C 2025 R2, not 41, Comet Swan will be closest today to the Earth, October 20th. Both comets have nucleus slightly larger than 2 kilometers, so not 1.2 kilometers, but that's really hard to ascertain with any degree of accuracy. Lemon will come in within 90 million kilometers of Earth, and it might, maybe, under ideal conditions, if you know where to look, be naked eye visible. Now, I was thinking of trying to photograph this tonight, and it's not in a good position to be photographed. Okay, where I am and Mary Helen is here in Canada, it basically is below the horizon from where I am. I mean, I could probably, if I went out to a totally flat farmer's field, maybe get it a little bit. It orbits the sun every 1,350 years as opposed to every 15,000 years. Now, Comet Swan comes closer and it's a bit easier to find, but it is a fainter object. And it's going to be about 24 million kilometers from Earth right about now, and it has an orbital period of 650 years. One of the things when it was on social media was people saying, well, how do they know it was going to be 15,000 years before it comes back? Was someone around 15,000 years ago to measure it? No, we can calculate the orbital dynamics of something by observing it. So we've got a pretty good idea of the orbital periods. For Lemon, it's 1350, and for Swan, it's 650 years. And there's some error bars on that, but that's all good. Now, if a comet were coming within 150,000 kilometers of Earth, it would totally dominate the night sky. Mary Helen just mentioned the passing through Halley's tail, which is several million miles long, and it totally dominated the night sky. It was never that close. Okay, if it was that close, we'd all be pretty terrified because we're not that good at measuring exactly the orbital parameters, and comets can break up, and it could be dropping junk on Earth or on the moon. We really don't know. It would be a big deal if it was coming that close to the Earth. It would be terrified, and rightfully. That's really close for a
I know,
comet.
it just, if you think about it, the halo around the nucleus can get up to tens of thousand kilometers across. You'd almost, if it's that close, you'd almost be in the halo around the nucleus, right? Never mind the tail. Um,
I know,
it's
it's
just
like
like that's
insane.
just you can tell these people know nothing at all about what they are talking about when they say stuff like that, but they see a big number, right?
Yeah,
And
it's
150,000 kilometers away, that seems really far, except the
it's
nucleus might only be a kilometer, but that halo that surrounds it can go out to tens of thousands of kilometers. You'd almost be
it's
inside the halo if it's that close. Um,
yeah, it was absolutely insane. And the worst of it was people, people the way they were tripping, saying that you had people saying, "Oh, this is predicting the end of the world," or the beginning of the. One person was beginning. This would bring on a global increase in awareness and open the dawn of a new age for mankind. Now,
Yeah, but like it's not just social media that brings these out. It makes it worse. But let's be honest,
it
Hale Bopp brought out a lot of nutcases. You
it
had the
did,
Heaven's
and that
Gate.
was before Facebook. Yeah,
I know, and that
absolutely.
was and that was the whole Heaven's Gate problem. And if you go back even
Yeah.
to 1910, if you read some of the articles, they were having end of the world parties, and it's like you said, oh, we've detected cyanide in the tail, and it's going to gas us all. And they were having like selling like you said gas mask and comet pills, and there was a certain amount of this going on. So. Social media may make it worse, but this is human nature,
This is
unfortunately,
this is
to be
a
like this.
human
Yeah.
phenomena. Yeah,
This is a
yeah,
human phenomenon. Social media may amplify it, and let some people's sort of imagination run worth. But these were like newspapers and stuff in the 1910s that were publishing this. So,
oh, I know.
it's always been there. It's just
Yes,
it has a farther reach when you have social media that can reach, people around the globe rather than a newspaper that, may reach a few tens of thousands of people, assuming they even read it and pay any attention. Um,
yeah, it's
to it.
yeah.
So it's
And as to being a rare event, two comments at once is kind of neat. And I guess you could say there's three really cool comets because we've also got our interstellar comet Atlas 3I, which we talked about earlier. Comets are wonderful. I've been fortunate enough, as I said, to see several in my life, but they are relatively dim and they're pretty commonplace. There's always comets being discovered. Occasionally, every couple of years ago, we get one that might be naked visible and garner some public interest. Interestingly, a year ago, for all how rare these events are, there was a nighttime visible comet
yeah,
seen after sunset. People forget that was exactly a year ago. It was
yeah.
I remember because it was in Reading Week last year that you could see it, and this year we've got this just after Reading Week. But I guess the object lesson here is when it comes to astronomy or other areas for that matter, don't think of social media as a news or science source. Think of it as a fun source. But you know, the universe is wonderful and it's delightful and it throws great things at us, but not everything is once in a lifetime. There's lots of chances to see all this stuff.
What is it? There's probably like two comets that come into the inner solar system every month, even though we can't see most of
Oh,
them
yeah.
because they're so faint. So
Maybe
comets are
more.
actually, yeah, the comets are actually fairly common.
They
It's just
are.
that they're usually too small to be seen without a
Yes, that's,
telescope and without
yeah,
following
absolutely.
them. So,
But
yeah.
we have to look for them because, dinosaurs didn't have a space program. Okay, so,
Well, we,
um,
we 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 had an even closer call if you want to talk like 1914 was it the one out in Siberia. Oh, no, I'm brain.
oh, and was it? I think it was 1910. No, it was
Yeah.
1914. It was 1914.
Yeah, 'cause it
Yeah.
was right during the Russian Revolution when you had the Tunguska impact. And it's
Yes,
like
that's
someone
right.
said, had that been an hour or two earlier, it might have wiped out Moscow.
Yeah,
It was just
yeah,
highly, highly lucky. And the weird thing is it didn't really leave any kind of impact. So I think that one may actually have been an airburst,
yeah. It probably was.
possibly a comet impact too. So, or a
Yeah,
comet airburst. But if you've seen the pictures, it wiped out huge amounts of territory.
flattened it.
And yet that one went almost unnoticed. It was kind of funny just because of where it hit and the politics of the time and how, unreachable Siberia was. It's sort of like that's kind of weird if you think about it. We
Yeah,
actually did get hit and almost nobody noticed.
yeah. So, but it's interesting. Again, take social media for what it is. It's a place to meet our friends and chat and have fun. It's not science. It doesn't provide us a lot of scientific merit, and it doesn't provide a lot of news. Um, but Mary Helen, our last story. I'll turn this one
For
over
our
to you.
last one, we'll get to quickly. Of course, we've talked about space missions and all this kind of thing. And, going forward, the US is still trying to get back to the moon. They're now starting to engage in another space race, except this time with China instead of the Soviet Union. And of course, they've put a bunch of their space program eggs into the Elon Musk's space company, SpaceX. And so Starship Vinyl 2 had its final test flight. He has not been doing well recently with his test flights, as we've all heard about a number of the explosions that have occurred either on the pad or not long after takeoff, and some of the other problems. So the Starship had a test flight just recently. Again, all the technical details of how many, which one it was in the series and all that kind of thing. It did manage to fly. It did have a fairly reasonably successful flight, but they're falling behind, right? This is the problem with the Starship program, is some of the setbacks they've had earlier this year now has NASA kind of worried that they're not going to be able to make it in time. Um, Unfortunately, SpaceX's approaches to spaceflight is let's just keep launching them, and when we blow up, we'll figure what we did wrong and fix it the next time. But it's more space flight's quite complicated. Like you can't just do that sort of wreck it and figure out how to make it happen the next time, because you just can't launch that many sometimes, right? Um, so they're going through the process of testing, but NASA's now very worried that they're not going to be able to do it in time. So they're starting to talk about potentially, and I think you pointed, you were chatting about this article before the show that, NASA may pull some of that, contracts away from SpaceX if they can't get their stuff together pretty quick to provide this sort of heavy lift duty. I mean, Bezos has his Blue Origin out there, and there's various other groups that have been working on this to see if they can, pull together a rocket to actually put humans back on the moon. So it's like I said, SpaceX continues to launch, but they haven't been as successful, at getting this together. And they unfortunately take a very sort of, I don't know, I'd call it a bit cavalier approach to getting things to work. Space is dangerous. I mean, the essence of a rocket is a giant bomb that's, sitting underneath you, and you hope you can direct the energy in the right direction to get you into orbit instead of blowing you up. So,
I think
and so
that
it's, yeah.
I think what we'd have to say is that, uh, and we're getting near our time, but we'd have to say that they need to start looking at other options, and they're starting to do it, because the approach that SpaceX is taking with multiple missions, refueled in space. Um, I'm, every time I look at a drawing of the SpaceX lander on the moon, I sit there and say, would someone please tell Elon about the center of gravity? Because the thing looks like it would fall over in a second, and you don't want that with people on it.
I know
So, the Apollo lunar lander was wider, its legs were wider than the thing was tall. And this thing's, 15 meters tall. It's insane. Anyway, we're at time, so I think I'll just sign off by saying you've been listening to York University Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Professor Mary Helen Armour and myself, Paul Mackin. The podcast and past episodes are available wherever podcasts are distributed. You can always connect with us on Instagram at the handle at York U Observatory, or on Facebook at Allan I Carswell Ob. Our website is yorku.ca/science/observatory. And there we have a lot of interesting content. And if you feel so inclined, it is a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. Don't pay attention to social media for science. Thanks for tuning in this evening. We wish you clear skies and have a good night.